continue with our chapter 1, that is locating places on earth. We'll be starting with latitudes. Let us return to the globe. It is easy to identify the North Pole and the South Pole on it. So rotate the globe. While it rotates, the two fixed, that is the top and the bottom, are the two poles. Halfway between them is the equator. Note the circle marking it. So this is the North Pole, South Pole, and the equator at the center. We are asked to imagine that we stand on the equator and travel towards one of the poles. Your length from the equator will increase. So the latitude measures the length from the equator. And at any point of this travel, you can draw an imaginary line that runs east to west, which is parallel to the equator. Such a line is called the parallel of the latitude, and it draws a circle around the earth. Again, it is easy to note on the globe that the largest circle is the equator, while the circles marked as the parallel of the latitude grow shorter as we move northwards or southwards. So here we can observe that this is the equator and these are all the parallels of the latitude lines. So this will be the largest and the rest all will keep on reducing until we reach the north or the south pole. We need to note that these are the parallel of latitudes. Next, latitudes are expressed in these terms. By convention, the latitude is 0 degrees, while the latitudes of two poles are 90 degrees north and 90 degrees south respectively. So this is noted as 90 degrees N and 90 degrees S. So there is a connection between the latitude and climate. So around the equator, the climate is generally hot. It is also called as follows. And as we travel away from the equator towards one of the two poles, in other words, when our latitude will increase, then the climate becomes more moderate, or it becomes a milder, and it is closer to the north or the south pole, then the climate will become more cooler. So here we can observe in the diagram that near the equator it will be hot, while the degrees will keep on reducing until we reach the north pole, and the north pole it will be the coldest places. That is what they are trying to tell in this whole. Now we'll be moving to the longitudes. Longitudes are these lines which are actually perpendicular to the latitudes. So these are the longitudes and these are the latitudes. So imagine now that you travel from the North Pole to the South Pole by the shortest possible line. Observe the globe and you'll see that instead of passing from Europe and Africa, you just pass by through Asia. So here the length would be the same. So these lines are called the meridians of longitude. So there we used to call the parallel of latitude, while here we call the meridians of longitude, and they are the half circles running from one pole to the other. You will also learn in science that the earth spins on its axis. It is important to note that the earth spins on its axis, and to make it simple, let's place a lamp a little away from the globe and focus on it. And now imagine this is the sun illuminating the earth. So slowly rotating the globe eastwards, we can see that there are some places on the earth in the morning, while the others in the midday, that is evening or the night. So it's breakfast in one country, it is lunchtime in the other, and the third may have already slept. So this is why measuring the longitude of a place will also be the measuring at what area the place is located, or what the people do at that particular place. So to measure the longitudes, we need to actually define a reference point called the prime meridian. It is important to note it is called the prime meridian. It is also called the Greenwich Mean Meridian because in the year 1884, some nations have said that the meridian passing through the Greenwich, an area in London, that is in England, would become the international standard for the prime meridian, and it is marked as 0 degrees longitude. So just as the latitude is a measure of the length from the equator, if you travel towards one of the poles, longitude is the measure of the length from the prime meridian. It is important to note that the latitude is with respect to the equator, while longitude is with respect to the prime meridian. And longitude too is measured in degrees. So westward or eastward, it increases in value from 0 degrees to 180 degrees, and with the letter W or E which is added. So for instance, using the round figures, New York's longitude is 74 degrees W, while that of Tokyo or any other place can be represented with either W or E. So it is important to note that latitude and longitude together are the two coordinates of a place. With them, you will now be able to locate any place on the earth. You can now understand a statement such as Delhi lies on 29 degrees N latitude or 77 degrees E longitude. These values are rounded off and not exact. So we can't say that there always be whole numbers. They can also be in integers or in points. And shows that the parallel of latitude and meridians together on the globe as blue lines. So all these lines together constitute a grid for the globe, and they are called the grid lines. So here, this is a sketch which shows how the prime meridian will divide the earth into the western hemisphere and the eastern hemisphere, while the equator will divide the earth into northern hemisphere and southern hemisphere. So by the equator, if we divide, we'll get both north and south hemispheres, while with the Greenwich meridian we'll divide, we'll get the western and the eastern hemispheres. So here, the Greenwich Mean Time is not the first prime meridian. There were others in the past. In fact, many centuries before Europe, India had a prime meridian of its own, and we called the Madhya Rekha or the middle line, and passed through the city of Ujjain, which was a reputed center for astronomy over many centuries. Varahamihira, a famous astronomer, lived and worked there for some 1500 years ago. So Indian astronomers were aware of concepts of latitude and longitude, including the need for a zero or a prime meridian. The Ujjaini meridian became a reference for calculations in the Indian astronomical studies. So this is the map which shows a few ancient Indian cities close to Ujjaini meridian, and some are very close to it while others are a little away. This is because measuring longitude requires accurate keeping of the time, which is not precise then as it is of now. So this is the map. And this is the map which is published by Survey of India, which actually set up the specific symbols for representing on the maps and shows that the country is outlined along with a few parallaxes of latitude and meridians of longitude. Next, we'll understand what are the different zones of. It is important to study this concept because when the earth is rotating, each country will have various hours of their working, sunrise and sunset. So it is important to study these zones. So let's make the globe rotate again from west to east, and that is how our planet spins around its axis, making a full turn every 24 hours. It is important to remember that it will rotate every 24 hours. So a full turn is a 360 degrees. So this means that 15 degrees per hour. It is important to note Earth rotates 15 degrees per hour. Now let us mark the meridians of the longitude every 15 degrees. Moving eastwards from the prime meridian, we get 0 degrees, 15 degrees, 30, 45 and so on. And every 15 degrees to 180 degrees, it is the same as adding 1 hour of the local time with each meridian. So if it is 12 p.m. or noon at the Greenwich, it could be 1 p.m. local at the 15 degrees E or 2 p.m. at 30 degrees E and so on. So but going westwards, it is the other way around, that is 11 a.m. local time at 15 degrees, and the time will keep on changing. So the same method can be used to calculate the local time of any place on the earth, but it could not be convenient for a country to use many local times. That is why countries would adopt a standard specific set based on the meridian passing through them. So the Indian Standard Time is 5 hours 30 seconds, as noted 5.5 hours, and ahead of the local, that is of the Greenwich Mean Time. So it is important to note that we call the standard to be the Greenwich Mean Time or the GMT. So all these standards are organized in the zones which broadly follow the zones of 15 degrees in the graph. But let us understand the world map, and we'll see that the lines dividing the time zones are not fully straight. This is because they have to respect each country's standard time, and therefore they follow the international boundaries. So we follow the international boundaries. So the numbers written inside some countries are the numbers of the hours to be added to the GMT to get their standard times. For India, it is 5.5 hours. That is, it has a positive sign or subtracted from the GMT if it has a negative sign. So here we can study the map and understand the various zones. Similarly, the globe centered on India shows the standard times with respect to GMT for a few countries. So finally, while the prime meridian is fixed at the Greenwich, the opposite line at approximately 180 degrees longitude is called the international date line. So as you can see the map, plus 12 and minus 12, so the time zones will actually overlap. So if you cross it by ship or a plane, you need to change the date in your watch. So this can be observed, that is plus 12 and minus 12, and then we need to change the date in your watch. So by traveling eastwards, you could subtract a day, say from Monday to Sunday, and if you cross it traveling westwards, you could add a day, that is Sunday to Monday. We said that the international date is approximately 180 degrees longitude, as it deviates in places to avoid the dividing some countries into two different days. So with this, we have completed the part 2 of our chapter, and these are the summary points which we have already completed in the chapter. It is important to go through them as well, and these are the questions, NCERT questions, which we'll be solving